Well, congratulations guys, you made it to the last day of notes for Trig Chapter 3. We only have a couple more days of notes for the whole year actually. Today we're going to use the graphing calculator to basically find our answers. So first thing we have to talk about is period of a function. Hopefully you guys remember that when we are dealing with sine x and cosine x, the period is 2 pi. It would help if my pen decided to write. Oh, there it goes. So the period's 2 pi. The cosine, the period is also 2 pi. And again, the period means how long it takes for it to complete one cycle of the graph. And tangent was pi. It repeats itself every period, or every pi radians. When you square sine, let's look at this in the calculator real quick. If I go to y equals and I type in sine x, and then remember, you're squaring the whole thing, so you could do it like this. Squared, and if I make my window go from 0 to 360 or 0 to 2 pi and I graph it, now notice how there were 2 cycles here. So the period's not 360 anymore, it's now 180. So I'm going to say that my period is 180 or pi. That means cosine will also be pi. Now tangent, don't get mixed up on it. You don't divide that one by 2, because what happens is it flips up, but it's still one cycle every pi. If we graph that, it would look the same. And then finally, sine times cosine. If you do that, it's like a sine squared or a cosine squared. You also get a pi. Again, you don't have to memorize these. You can just look at your calculator. Period can also be found using 2 pi over b. Remember, it's the frequency. It's 2 pi divided by the frequency, and because this number again is the frequency, we talked about that when we were graphing in Trig Chapter 2, and we can do pi over b for tangent. So for example, normally the period for sine is 2 pi, but if I divide that by the frequency of 2, that's going to have a period of pi. Cosine of 4 pi normally has a cosine of 4x normally has a period of 2 pi, but we're dividing by the frequency of 4. The period of this will be pi over 2. Again, you can look at your calculator. 6x for tangent of 6x. Normally the the period is pi for tangent. If I divide by the frequency, then the new period is pi over 6. Okay, that's just a little bit to work with here. So use the graphing calculator to find the general solution for each equation. Remember that theta refers to degrees and x refers to radians. So right away, these are in radians, these first two. Okay? Now here's what you do. You got to first of all type in, first of all you want everything moved over, which it is. This is going to be your y1, this is going to be your y2. And then you find out where they intersect. I like to always start with a window for my x of 0 for my x min to x max is, in this case, it'll be 2 pi, and make sure you're in radian mode. And then just to see the curves, y min, I make a -10, and x or y max, I make a 10. All that's doing is telling me how high or low the graph goes, and here I'm looking at one period of 2 pi. That does not mean that the period is 2 pi, but it could be. So we're going to look at it and see. Alright, so to type this in the calculator, we're going to type in our y1, tangent of x squared, minus, remember secant we can't type into the calculator as secant, but we can type in 1 over cosine of x, and then minus 1, and then y2 is going to be 0. Alright, so I'm going to enter that in real quick, and then I will show you what I got, so you guys should be doing the same. Once you type in the equation, you should get something that looks like this. If you guys need to just double check, you can pause your screen right now and look at what you have here. So pause if you need to double check that you typed it in right. The window will be from 0 to 2 pi and -10 to 10. And again, make sure your mode is in I'm not in radians. Glad I just checked, or else the graph would have looked a little weird. So if I graph this, hopefully you see one cycle. So it's starting down here. It went up, it came down, but didn't go, so this is a different part, and then it came down here. So this is one complete cycle because it has to repeat itself. It hasn't repeated itself yet until down here. Then this would come back over here and end up being the same thing. So this is one cycle. So now you just look for the intersection points. It looks like we're going to have 3 answers for every cycle. This one, and this one. Here's how you do this in the calculator to get an exact answer in radians. Second trace 5. First of all, let's find the middle one, because look at right there, it's already given to us. You guys don't even have to do the method that I was going to show you. 3.1415927. You guys should recognize that as pi, hopefully. Okay. Now, if you don't, you could do the method we're going to do for the other two. So one of my answers is pi. So if I go over here, my answer is pi plus whatever the period is, which is 2 pi k. Because every excuse me, every thing that goes on, you're going to see the same cycle if we kept the curve going. Remember, it goes on forever. We're just looking at one window of it. So we need all the solutions. So we have that one. We need to get the other 2 plus the period. So second trace 5. And then I'm going to move to the left and get this one here. Now here's what I was talking about. Do you see in the box in your notes it says when your calculator finds it, it stores it. Alright, so 1.0471976. My calculator has that stored as my x variable right now. So if you hit clear and clear to get back to the home screen, x, if you hit x, you should get that same number, right? Well, if you want to know what the radian is of that, just divide that answer by pi. Because remember, that's pi something. Sure enough, there's our fraction, math fraction. Hopefully you guys recognize that as 1/3, which means that that intersection point is at pi over 3. So I'm going to write pi over 3 plus 2 pi k. We need one more, so I'm going to do that one now. And I'm not going to do all of these every time. I just want to show you the process, so there's a couple of things that you can see and look back at on how to do. Sorry, this takes forever on this thing. Alright, here we go. So, enter, enter, enter. Okay, so now x is storing this number here. So again, you can clear twice. You can do x divided by pi to get the fraction. There's your fraction. Math fraction, though, to see what it is, it's 5/3. So 5/3 pi. So, or 5 pi over 3 if you want to call it that. And there we are. We have our 3 answers. Done. Alright, next problem. Again, move it over first. So I have 4 sine x cosine x minus root 3 equals 0. This is going to be my y1. This is going to be my y2. I'm going to use the same window at first. Okay? Because I like to start at 2 pi just to double check. Now, up above we actually talked about what sine x cosine x's period is. However, if you don't know what that is and don't remember, let's just graph it, okay? Alright. Again, take your time, pause it to just type this into your calculator. It should look like this. Your window should stay the same. 0 to 2 pi, negative 10 to 10, and I graph it. And I want to see if the period's really 2 pi or if it's going to be pi. So I look. Oh, there are 2 curves. 1, it ends up here. 2, ends back here. Which means that the period is not 2 pi. It's going to be pi instead. So I go back to my window to fix it and change my x max to pi instead of 2 pi. So I just see 1 cycle. And now I should see just 1 cycle. And sure enough, that's what I see. So that's 1 full cycle. It ends back up where it started. And I have 2 intersection points here. Okay? Again, with radians, second trace 5, I'm just going to hit enter 3 times where I am. It'll give me the one closest to it. You get that number there. and hopefully you guys remember that one from the last problem we did. When we divide out pi, so I'm going to clear, I'm going to do x divided by pi, and then hit enter. That's 1/3 pi. Now here's the difference though. The period is actually pi, not 2 pi for this problem. So my final answer is just going to be pi over 3 plus pi k, not 2 pi k. You have to figure out what your period is. And then the other problem, other one, you have to hit, again, second trace 5, move over to it, right, and then enter a couple times, and you get that number right there, 0.5235. Again, clear it. You do x divided by pi. Okay, and you get that. And hopefully you guys realize that that is pi over 6, but if you don't, you can just hit math fraction and get 1/6. And we can write that out. And since there was only 2 in one cycle, that's all we're going to care about. Because, yeah, you could have done all 4 and said 2 pi, but that's redundant. These take care of themselves as you keep going. Okay, so let's go to the next 2. Got 2 more. Now, notice how theta it's now theta. So we are now in degree mode. All that I changed for degree mode is that my mode, or my window I should say, I'm going to change my window. So I'm from 0 in the x-min to x-max is 360. Everything else stays the same, and you have to change to degrees. So I'm going to move this over, and I get sine of 2 theta, cosine of 64, which is a number, not a variable. So cosine 2 theta sine of 64 minus root 3 over 2 equals 0. So this is my y1. This is my y2. These are actually easier, the degrees, because you get a nice answer. So let's type that in. Pause on the screen here to double check that you've typed it in correctly. Just take the time to do that. And then the things we have to change our window from 0 to 360 first. I might have said 180. I should have said 360. I want to look at 2 pi and see if, and then figure out what the period is. And then I want to change my mode to degrees. Make sure you do that, or else you're going to get something weird. If you get something weird, that's probably what happened. So I graph this, and I look at it. Okay. So right away it looks like there are 2 cycles here, not 1, which means that the period is actually 180. So what I'm going to do is change my window to get x max is 180. And I'm going to actually change my y min and max to -1 and 1, because -10 and 10 I didn't see a lot there. I'm going to do -1 and 1 to make it smaller, and then double check. So here's my curve. We don't see the bottom of it, but we do know that this is one cycle because we looked at it, and it should come up right to the top now, where it would end up later. Okay, so we're going to find the intersection point here and here. It hits it twice. It doesn't hit it over here because it's hitting it over there. Second trace 5. Yeah, if you can't see where the curve's intersecting, make your y min and max smaller. 28 degrees. Alright, so we got 28 degrees. I'm going to keep that in my mind and get the other one real quick while I'm on here. Oh, let me do this. There we go. And again, if you try to do it over there, and if let's say you thought there was an intersection point at 0, if you try to do that, your calculator will jump to the 28 because there's no intersection on that side. It's actually over here. So you hit enter, 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 and you get 178. So the 2 answers for this problem are, my answers are 28 degrees plus, again, we talked about this, the period is 180K for this one, and 178 degrees plus 180K. It is not 360 because 360 gave us 2 cycles. And you could have guessed that anyway, because if you look, and we talked about this, if it says sine of 2 theta, you divide by 2 pi by 2, you get a period of pi, or 180. Alright, last one. Again, move everything over. So the y1 will be this. This is a big, crazy one. Now this one might be a little nuts because it's tan of 10 theta. So our period might actually be something crazy like 36 degrees. So what you keep doing is dividing by 2. Let me keep writing this. Right. We'll talk about that when we get to the calculator part. Minus root 3 over 3. Again, move everything over and set it equal to 0. It's easier to see that. So this is what you should be typing in. So pause. I'll pause the video and type that in myself right now. Alright, so double check this. Alright, and we have this. I know it looks like a mess. So what you want to do, and again, you can either jump right to what you think the period is. Remember what we talked about? If it's tangent of 10 theta, the frequency is a 10, which means that, and you should remember that the period of a tangent curve is 180, not 360. So, but if you forget that, let's just make it 0 to 180, because, again, tangent has a period of 180. If I graph that, I might see a bunch of curves. And sure enough, do you see how it keeps repeating itself? And it'll probably be 10 times. Okay, so if you get something where you have a multiple cycles like this, you have to divide the period by how many cycles there are. So we're going to get 10 of them because that's what happens. So instead, this one I want to just look at one cycle. Alright, so that's what you get when you do the full 180 degree period for a tangent curve. But remember, 180 divided by 10, because again our frequency is 10 here, we get 18 degrees. So our period's probably 18 degrees. So let's go back to our window, and instead of making it 0 to 180, let's just make it 0 to 18 and see if that gives us just one curve. It should. I don't know where it is, but okay, there it is. Alright, so there's 0 to 18. That'll give you one full curve, because there's the start of the curve. It comes down and gets back to where it began. We just have one intersection point. And again, we're in degree mode because it's in theta. And our answer is 16 degrees. So for this problem, we're just going to write that our answer is 16 degrees plus the period, which happened to be 18 this time, k. And that's our final answer. Alright, that is it. That's all the stuff for this chapter. Hopefully you guys practice the calculator stuff and the solving by hand stuff, because that's a part of the test that people struggle with. So I will see you guys later.